Hey guys, in this video we are going to be doing lesson 6.6. So we're solving polynomials by factoring. This means that when we solve them, we're finding the x-intercepts. And you're not going to be happy with me, but you are going to have to be using quadratic formula and those imaginary numbers, what you learned in quadratics, we're going to have to refresh on that. So somewhere at the top, just real small, let's write in the quadratic formula just so you have it handy. It's negative b plus or minus the square root of b squared minus 4ac all over 2a. And remember, the square root of -1, what is that? I. You'll have to remember that too. All right, so what we're going to do is we want to get our equation set equal to 0, meaning we get everything on the same side, and then we're going to factor it completely. And then we take each factor and set equal to 0. Sometimes that'll be really easy, really quick. We won't need quadratic formula, but sometimes we will. All right, so number 1, it is set equal to 0. Always look for a GCF first. So in this case, I can factor out x to get x squared plus 1. And then look in my factor, x squared plus 1. Does that fit anything else? Is that a difference of squares? No, because it's addition. And those aren't perfect cubes. That x squared would need, that exponent would need to be a multiple of 3. So that's all we can do. And so then we take each factor and set equal to 0. The first one, x equals 0, that's easy. It's just x equals 0. And then we have x squared plus 1 equals 0. We subtract 1 from both sides to get x squared equals -1. And then we take the square root. So x equals, the square root of -1 is I. And remember, we always write plus or minus in front of it. So plus or minus I. So positive I and negative I. And those are the x-intercepts. Number 2, this one is not set equal to 0. So we need to subtract 3x squared from both sides. Then we look for a GCF, and I can take out a 2x squared, and that leaves me with 2x minus 5. Okay. So then I take each of the factors and set them equal to 0. So if I divide by 2, we get x squared equals 0. And then I take the square root, x equals 0. Then we add 5 to get 2x equals 5. And then we divide by 2 to get x equals, you can leave it as a fraction or you can change it to a decimal, either way. So not too bad yet. It's coming though. All right. Number 3. I don't see a GCF. So let's think about what other things we've got. This is 2 terms, so you're going to have to do either difference of squares or sum of difference of cubes. It is a difference, and we have 2 perfect squares. So difference of squares. So remember, you take the square root of both sides. This is x squared. This is 8. And so when we factor, we do x squared plus 8, x squared minus 8. And then we check to see if those are perfect squares, but they're not, so we can't factor anything down anymore. And they're not perfect cubes. All right, so if we take x squared plus 8 equals 0, we need to subtract 8 from both sides to get x squared equals -8. And then we take the square root. Now 8 is not a perfect square, so remember back to when we simplified radicals. So the first thing we pull out is the -1. Make sure when you're dividing this up, you're bringing the square root with it. A lot of you just write -1 there. Make sure that you're bringing the square root. And then we say, all right, what is the largest perfect square that goes into 8? And that's 4 and 2. But square, because that was the square root of 8, so I'm bringing down my square roots. Now, what is the square root of -1? It's I. What is the square root of 4? 2. And then the square root of 2 doesn't simplify. So when I put it together, x equals plus or minus 2i radical 2. Now let's do this one. X squared minus 8 equals 0. So we add 8. To get x squared equals 8. And then I take the square root. Now I just simplified that over here. You don't have to rewrite it. The only difference is this time there's not a negative, so the I is not part of our answer. So just plus or minus 2 radical 2. You will be seeing a lot of these simplifying radicals, probably in these examples. All right, number 4, look for a GCF, and it does have one, 5x. So when I divide out 5x, we get x to the 4th minus 16. And this is a difference of squares. So the square root of both of those, we have x squared plus 4, x squared minus 4. Guess what? This is a difference of squares. So this stays. This stays, and then we have difference of squares. X plus 2, x minus 2. Now we're going to take each factor and set each factor equal to 0. So if we divide by 5, we get x equals 0. So if we subtract 4, we get x squared equals -4. And then we take the square root, so x equals, now 4 is a perfect square. We know the square root of 4 is 2, but that negative means we have to write the I with the answer. So plus or minus 2i. Then we have x plus 2 equals 0. So subtracting 2 gives us x equals -2. And x minus 2 equals 0. So adding 2 gives us x equals 2. All right, number 5. This one does not have a GCF. It's straight up sum of cubes. So the cubed root of x cubed is x. Cubed root of 125 is 5. So when we factor, we get x plus 5. And then in parentheses, we have x squared minus 5x plus 25. Whenever you do sum of cubes or difference of cubes, that trinomial right here probably isn't going to factor down at all. And so that means we're always going to have to do quadratic formula with the sum or difference of cubes. But this x plus 5, that one's easy. Subtract 5, we get x equals -5. The other one, let's just do quadratic formula. So negative, remember your b is here in the middle, so that would be -5 is just 5 plus or minus the square root of b squared minus 4ac all over 2a. Now remember, you have to type in just the numbers under the square root. You don't type in the actual square root button. And you get -75 over 2. Now here to the side, we need to simplify this radical. The -1 comes out, and then you ask yourself, what is the largest perfect square that goes into 75? And that number is 25. 25 and 3. So this turns into I. This turns into 5. This doesn't turn into anything. So we get 5 plus or minus 5i radical 3 over 2. All right, next one. We need to subtract 4x squared first. 8x to the 5th plus x squared. So this has a GCF of x squared. And then we have sum of cubes. Cubed root, not square root. So the cubed root of 8x cubed is 2x. And the cubed root of 1 is 1. So when I factor, I still have the x, oh mercy, I still have the x squared. Then we have 2x plus 1. Then 4x squared minus 2x plus 1. Might need to make sure you're writing pretty small here. All right, so we got to take each factor and set each factor equal to 0. Well, the square root of 0 is just 0. Okay, if we subtract 1, we get 2x equals negative 1. And then dividing by 2, x equals negative 1/2. All right, and then the last one, we're gonna have to do Pythagorean theorem. So negative b, that's gonna be a positive 2, plus or minus the square root of b squared minus 4ac all over 2a. Remember, we just type in the numbers under the square root. Don't actually use the square root button now. And we get negative 12 over 8. So now remember, we got to go to the side and simplify that radical. Take out the negative 1. What is the largest perfect square that goes into 12? It's 4. 4 and 3. So this turns into I, this turns into 2. That stays radical 3. 2i radical 3 over 8. But remember, we look at these three numbers to see if there's anything that I can divide them by, and I can divide them all by 2. So 1 plus or minus 1i radical 3 over 4. Let's do a couple more. Let's just skip down to number 11. I'm just going to skip around and do some different types here. So this one has a GCF of x. That leaves me with x squared minus 8x plus 16. And here we have a trinomial. So we're going to see if we can factor this. What goes in, or what multiplies to be 16 but adds to be negative 8. Think about it for a second. It's negative 4 and negative 4. So this becomes x minus 4, x minus 4. And then we take each factor and set each factor equal to 0. So if we add 4, we get x equals 4. Now we have 2 of those. And remember, when we have 2, we call that a multiplicity of 2. You don't write it twice, but we would say that it has a multiplicity of 2. All right, let's look at number 12. This one has a GCF of x squared. No, 2x squared actually. And remember, we've done a few examples where we have a trinomial that's x to the 4th and then x squared. Remember, the only difference is instead of writing like x plus 2, we would write x squared plus 2. So we want two numbers that multiply to be negative 24, but add to be negative 5. Think about those two numbers. Try to figure those out here. Those would be negative 8 and 3. So when we factor, bring down your GCF, we have x squared minus 8 and x squared plus 3. A lot of times with these examples, you have another difference of squares, but we didn't this time. That x squared minus 8, 8's not a perfect square. So let's see, 2x squared equals 0. If you divide by 2, you get 0, and then taking the square root of 0 just gives you 0. Then we have x squared minus 8 equals 0. Adding 8 to both sides gives us x squared equals 8. And then the square root of 8, it's not a perfect square, so we want to know the largest perfect square that goes into 8. That number would be 4, 4 and 2. So x equals plus or minus 2 radical 2. Then we have x squared plus 3 equals 0. Subtracting 3 gives us x squared equals negative 3. And then we take the square root of both sides. Now, there is that negative, which comes out as I, but there's no perfect square that goes into 3, so we just leave it. And, oh, don't forget the plus or minus. I radical 3. All right, let's see if there's any grouping in here. Let's do one of these groupings and then we'll be done. So with grouping, remember we split down the middle. and we do the GCF of each side. Left side, I can factor out an x squared, x plus 2. And then over here, I can factor out a 5, x plus 2. So this factors to x squared plus 5, x plus 2. Now if I take each factor set equal to 0, we subtract 5 first, and then we take the square root. That negative comes out to make I, but nothing else goes into 5, so we just leave it. And plus or minus. Then we have x plus 2 equals 0. Subtracting 2 gives us x equals negative 2. I know this has been a long, complicated video, and you're probably banging your head against the wall. But as you do some practice with these, go back and maybe watch the videos of the examples that are similar to the ones you're trying to do, and that should help you if you follow those steps.